Alright, start here with 24. Um, they're asking us to find the equation of the tangent line at when x equals a negative 1. So this is the function here. So we're going to take the derivative so that we can find the slope. But since we're looking for an equation of a tangent line, let me remind you of something here. Remember, we have this formula: y minus the function value at a is equal to the derivative evaluated at a times x minus a. And this is just the point slope formula. And so we only have that we don't know what the function value is yet for a. We don't know the derivative yet, but we know we're going to evaluate it at a negative 1. And we know that a is at negative 1. So we do have this much information. So before we get started, I guess we could go ahead and plug in negative 1 to the original function over here, and we would have what? Negative 1 cubed minus 5 times negative 1, added 3 to it. So this is negative 1 times 4. So we have negative 4 plus 5 plus 3. So it looks like the y value is going to equal what? 4? Y value at this function value, negative 1, is 4. So we do have this much. And so let's go ahead and go back to the derivative portion so we can find the slope value right here. So we take the derivative at negative 1. So it's a fairly easy one, 12x squared minus 5. And so now that we found the derivative, we just simply go back in and evaluate it at negative 1. Alright, you should be able to get it from there, no problem. Okay, 25 is a, looks like it's a position function. And let me just remind you of this PVA, position, velocity, acceleration. So when we go down the chain, we take the derivative. To get from the derivative of position, we take it, we get velocity. To take the derivative of velocity would take us to acceleration. And then, of course, if we need to go the other direction, we would integrate. Alright, well, they're asking us, when is the particle at rest? So when something's at rest, it has a velocity equal to 0. So we're just going to take this derivative and set it equal to 0 and see what we get. So let me give you a little hint on this one. It's not really too complicated, but taking the derivative of the position is going to equal the velocity. So we have 6t squared minus 21 times 2 is 42 t to the first plus 72, and of course this part goes to 0. So to make factoring easier, we probably make a note that all these can be divided by 6, looks like, and from here we get minus 7t plus 12. So since this term doesn't have an x involved with it, it's really not going to be significant for us, so we just need to factor this quadratic out and set it equal to 0. Alright, let's move on to 26. Number 26, looking at it, you'd probably think, since we have x's and y's over here in this term, and we have y squared here, we can't just say that y equals something. So we're going to use implicit differentiation with respect to x, and just take the derivative piece by piece. So let's use blue. So the derivative here would be 6y. We took the derivative of y, so we have to include the dy dx. Here we have minus 4x dx over dx. 6 is just a constant, turns to 0. And here we have, looks like we have to use a product rule, so we'll define this as f, and of course y can be g. And just a word of caution, a lot of times we lose track of that subtraction, so let me just put a big parentheses here. So f prime g would be the derivative of 2x is 2 y. We don't put dy dx because we took the derivative of x, plus the derivative of, don't touch 2x, and we did take the derivative of y, which is 1 dy dx. So now all we have to do is collect all the dy dx's on one side of the equation, move everything else to the right, and then solve for dy dx. So I'll just kind of move things around over here. Now we got to be careful with that. We're distributing a negative sign to both sides. So this actually turns out to be what? That's a negative, and that's a negative. So moving everything over, you move a negative 2x over, it becomes plus 2x dy dx. And then let's move this minus 4x over to the other side by adding it. And we have a negative 2y, it looks like. And factor out the dy dx term. So we have dy dx is 6y plus the 2x equals 4x minus 2y. Okay, so keep in mind that we're solving for the derivative here. And since you have an x and a y value already over here, instead of making an arithmetic mistake or algebra mistake, perhaps we should just go ahead and plug in our x and y values here, and then divide everything out. Alright, so good luck with that one. Alright, 27. We went over this a little bit, but not a whole lot in detail. So I'm going to spend a little bit of time with this. They're asking us basically to find, they're defining the derivative, or excuse me, they're defining g to be the inverse of x. And if you recall, if you make a composite function of itself with its inverse, remember they just define that as the inverse. If you do a composite function, f of g of x, it always equals x. So one way to do this problem is to take the derivative of this function. So if you take the derivative of the right side, it's equal to 1. And if you take the derivative of this is a chain rule problem by definition. The big picture is you're taking the function of f, but the inside portion would be g of x. So we have what? We have f prime of the inside stuff, and then what is the derivative of g? Which is g prime of x, right? Alright, well the problem is asking us to find the derivative of the inverse. So since all these terms are being multiplied, in case you forget the formula that I'm going to show you in a second, the derivative of the inverse is equal to 1 over that. So see how that works out for us. So this right here is basically a shortcut for you. If you, in case you forget the derivative formula for an inverse function. All right. So let's go ahead and take the derivative of this guy. The derivative of the original function is 3x squared plus 1. Alright, and then if you look back at the problem, I give you a couple of values. Let me pause this for a second so I can get my notes out. Okay, sorry about that. So I was looking for the function, or the inverse value. They gave us, I didn't write this down before, they gave us that the inverse at 2 equals 1. So what does that mean? Well, since g and f are inverses of each other, the x's and the y's switch places. So this is the x value for g, and this is the y value for g. So that means that this is the y value for the original function, and this is the x value for the original function. So let's go ahead and plug in not 2, but we're going to plug in 3 times 1 squared plus 1. So of course that equals 4. And what is the g of x? Well, g of 2 is equal to 1. That's what they stated here. So really what we have is 1 over 4 times 1. And so that gives us that the slope is equal to 1/4. Okay? Alright, on number 28, they gave us the statements, no functions, but they told us that the derivative is greater than 0, and the second derivative is always greater than 0. So, of course, this tells us that it's always concave up, and it's always increasing, right? So, it's not necessary to draw a sketch, but I thought it might be worth our while to sketch it. It looks something like this, perhaps. Always concave up, and always increasing. So they gave us a couple of points here. They told us that at 4 it was equal to 12, and they told us that at 5 it was equal to 18. Okay, so that's that value right there, and they're asking us, well, what could the possible value be at 6? Well, now we can eliminate a couple answers right off the bat, but notice something here, that this function value is increasing by a value of 6, right? It's going from 12 to 18. So since this function is increasing and its second derivative is increasing, that means the rate of this increase has to be greater than 6 as you move from 5 to 6. So we're going to take 18, and it has to be greater than 6, actually. So, but at 6 it would equal 24, and that would be if it remained constant. But since it's increasing, our answer has to be greater than 24. Greater than 24. So turns out not to be such a bad problem. It's just conceptually, do you see the picture? And remember, since this is a non-calculator section and 55 minutes comes and goes pretty quick, you kind of have to understand conceptually what's going on pretty quick in order for you to get through this entire test. So anyway, make sure you show me all your work, and my goal was for you to just start looking at the test in a different way, get a few tricks here and there, and this will help you get started. And we will see you guys after spring break.